Welcome to MaxxEcu Training Part 31. In this video, we're going to be exploring working with our basic idle control. In our basic idle control format, we're going to be allowing the engine to mechanically idle. We're going to be using airflow and spark time to achieve the desired idle RPM in idle conditions. We're going to be learning how we have idle torque and what influences the idle torque, and then using the MaxxEcu to achieve that certain level of idle torque between airflow and spark timing. There's a lot to cover. Let's jump into our video so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our basic idle control programming within our MaxxEcu. Our basic idle control assumes we're going to be after a mechanically based type of idle control where we don't have an idle control motor fitted to our engine, like a stepper motor or a pulse width modulated style motor that can allow more or less airflow into the engine. We're also going to be assuming we don't have drive-by-wire fitted to our engine, which can influence how much airflow is being ingested at the engine at idle conditions. This is going to assume we have a fixed throttle plate opening and a certain amount of spark timing that we're going to be using to achieve a certain idle target or certain idle RPM we want our engine to idle at when it's going to be warm. There's a lot of little details here. Let's jump in and take a look at the basics for mechanical idle control and just understanding what is going on here on a fundamental level that allows us to move into some of our programming details and make better sense at that point within the video. First thing I want to do is jump in here into our navigation window here on the side and go down under tuning. Under tuning, we have our ignition angle table. Now in our ignition angle table, this is where the base spark timing is commanded from. If we're taking a look at our idle conditions, that'll generally be from -3 to full engine vacuum and anywhere between 1200 and below in idle RPM, usually where we want most any engine to idle at. So in this range we're looking at here, the spark timing that we command in the table, that will influence how much engine torque production we're making. If we increase the spark timing here, that'll increase the cylinder pressure and therefore increase the engine's torque production. If we decrease the spark timing, that'll decrease the cylinder pressure the engine can generate and then decrease the engine's torque production. We'll find as the engine's torque changes, that will influence where the idle RPM is going to be at. So less engine torque, less engine RPM at idle, and then more engine torque, more RPM at idle, and we'll find we have a direct influence. Again, spark timing can be used to help feedback into the idle control. And that's only part of what is required to have a certain level of engine torque production. So we have to have our spark timing generated and the range that we need to be in. We also need a certain level of airflow coming into our engine and then having the fuel being adjusted according to the airflow. But we'll find that the airflow, if the airflow increases at idle, let's say in the case of no idle control motor and no drive-by-wire control, we would have to physically open up our throttle plate more at idle to allow more airflow in. If we allow more air in, then we raise our idle RPM. And as a result, we're basically in a roundabout way increasing the engine's torque production. So by either changing airflow or changing spark timing, we're influencing what the torque production is from the engine. So if we decrease airflow or decrease spark timing, that decreases engine torque. If we increase airflow or increase spark timing, or combination of both, that'll increase the engine's torque. Every engine will have a certain level of torque that it needs to maintain to achieve a certain idle speed. So on a 4-cylinder engine, we may find at idle conditions we only need to have maybe 8 or 9 or 10 pound-feet of torque to achieve an idle RPM of 1,000 RPM. Let's say then we don't want to have our idle idling at 1,000 on a warm engine. Maybe we want to have the idle at, let's say, 900. Well, we're going to have to decrease our engine torque. We might only need 8.5 pound-feet of torque to be able to achieve 900 RPM. The way that we're going to be hitting the idle RPM that we want to be at is a combination of our spark timing and our airflow. So pretty basic, but very powerful if you think about how it's going to be working and what we're going to be adjusting here in this basic mechanical format. Now, engines that would have this type of mechanical idle control would be a race engine, where you've deleted all of your no drive-by-wire and you've deleted your idle control motors. There's nothing fitted to the intake manifold. You just have a throttle body and you'll have your throttle plate that you can adjust. This is going to be an excellent way to control idle on a race engine. You don't need it to be really any more complicated than that. So this will be the fundamentals or the basics of any idle control. Once we understand everything I'm talking about in this video, the next few videos, we're gonna be looking at idle control, introducing an idle control motor, which will influence how much airflow comes into the engine, which will have an influence of the torque production over a longer area or wider area of control. Again, it'll make a bit more sense when we get into those videos. But for right now, we need to understand this concept, and it should be relatively simple to understand. Again, torque will influence idle RPM, and then we can drive the torque up or down to achieve the desired idle RPM we're at with either spark or airflow. Now, in the most basic format for idle control, we can have the max not doing anything, meaning we're going to be here at idle and we're going to move our spark timing values here up or down to raise the idle speed up or down. Now, we will find there's going to be a limitation of how much spark timing we can either add or take away to influence how much RPM movement we see at idle. So meaning you may find if you're at 10 degrees and your idle RPM is at 900 RPM, if you go up to 30 degrees of timing, your idle RPM may only go to 1200, 1250. Now, if you want to go and reduce your idle speed down, let's say we're at 10 degrees here and we're at roughly 900, maybe you want to idle at 700 RPM. If I went from 10 to 0 degrees, so retarding the timing and building less cylinder pressure, we should see as a result our idle RPM might go down to 750, maybe 700. It won't go much.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.